Yeah.
Smile. Maybe one more. It was not correctly oriented. It's hard to make a parallel photos with this.
Okay, and if this YouTube tab is open, Mia, please mute that tab also, because it will also produce sound. And this for Mia, you and me and Matthews, we need to mute or remove. Okay, yeah, that's all. And I'll. Where is the timer?
Are you looking for the timer website?
Jesus, everything is.
Okay, and Matthews, one more thing. Do you want me to tell you that what is the remaining time? Means 15 minutes, 30 minutes, something?
No. I will keep up the time. I hope I will be on time. I have enough slides for sure. I hope to have some time for Q&A at the end, so no worries.
Okay.
I have nearly 80 slides, or even more, for 90 minutes. It's quite a lot, but a regular pace will be fine.
Yeah, and yeah, we'll have to close on time, because then we'll have to go to AMA. That's a different room.
Yeah, actually, I'm worried about this a bit, because yesterday when I wanted to attend AMA, it was closed because it was already full. And I cannot go early to AMA right now, because basically I have to be to see Q&A in my talk.
Yeah.
So how would I get to the AMA if it's full?
Yeah, that will have to.
Because it will be hard to have a Q&A with me without me, right?
Right.
Yeah. Let me.
Okay. We'll
Jiraj, do you have any ideas, or I can ask in the volunteers channel?
You asked to Jim. I
Sure.
think Jim, or you ask in volunteer channel. I think Jim can give you direct answer.
Okay, I will go ahead and do that, so you can focus on just setting up.
Yeah. Okay. Okay, 9 minutes remaining. Let me put overlay on this. Okay. There is some noise I'm hearing.
Yeah, that's my keyboard. I go ahead and mute myself while I'm typing.
Okay, no problem.
You said I should start when I see this background, but it's too early right now.
No, we can talk. Means when I will remove this background, then you will have to start.
So when you remove it, yes, then I start.
Yes.
Okay.
Yes.
It's
I will
weird to
remove my.
start when you see the absence of
Actually,
something instead of when you
okay.
see something.
Oh, okay. Okay.
So
yes.
this is what you will see. This is what
Okay.
you will see
Mhm.
without
Okay,
me
then I
and
can
Mia.
start.
No,
Okay,
no,
I'm fine. I will remove this one soon, so I will not be able to hear you.
Yeah. Anyway, we will remove ourselves from this. So if there is anything we want to share you, we want to convey you, we'll use private chat.
Yeah,
Jim
I'm on
is
Slack.
also here.
I have my Slack open.
Hey guys, I just jumped in to check everything's okay.
I'm fine, thank you.
I hear there was this question about the AMA. We've now decided to do the AMAs in the same room that you're doing your broadcast in. You don't have to go to the AMA room anymore. You just carry on. It will just stay in broadcast mode in the same room.
Oh, it is really good because I was afraid I will not be able to get there. Yesterday when I tried, the room was full.
Yeah, so we switched it. We realized that didn't work. So you just stay in here. If you want to go to Remo, you can, but obviously you'll still be in StreamYard at the end of your session. If you prefer just to stay in StreamYard, that's fine, and we can just leave you there, and they'll just relay the questions to you like they would for the normal Q&A.
Okay, so I am in both Remo and StreamYard. So
Perfect.
do you recommend me to stay here in StreamYard or go back to Remo? What's the recommendation?
Stay in both. Open Remo, have that muted so you can see the presentation and you can see the questions. Then when you get to the end, just say to everyone, right, we're going to switch over to doing the AMA now, and you can just answer the questions as they come in from Remo. And we'll keep you in presentation mode inside of Remo, so it'll just be the same stream as if you just carry on the talk, and at the end of the talk, it's just like an extra 20 minutes of the talk, but you're now just doing the questions that come in. Does that make sense?
Yes, sure.
Perfect. Okay, great. As long as everyone's clear, that's wonderful, and I'll leave you alone.
Okay.
Okay, great.
Yeah.
See you later.
Okay. I need 1 minute and I'll be back.
Okay. Yeah. So Mia, means we'll not have to close this session, right? This will continue.
I think we just means we hang out until after the AMA is done with the same stream and everything.
So means ideally this will be 2 hours of broadcast, right? It's completely 1 hour for this and 1 hour.
Is the AMA 1 hour or just a half hour?
I think it's.
Here, I have it open. I can look. It looks like it's only 20 minutes scheduled, so this says it should end at 10:20 Mountain Time.
Okay. So we'll continue with this only.
Yeah, perfect.
Switch to remote everything. Okay, that's okay. So
maybe we should make a post in the general chat a little bit before the talk starts, just to let people know to stay in the room for the AMA, since there's been some changing of plans around that.
Yeah, that will be fine. Okay, we have 4 minutes to go live. Okay. Okay. Let me copy this link. Actually, this is first time I'm hosting this kind of big conference, so I'm a bit nervous now.
No worries.
Everything will be good. 3 minutes.
Works.
I'm going to remove myself from the stream so that I'm not up on the screen when you're doing your slides, but we'll both be available through the chat window if anything comes up.
Okay.
Good luck.
I'm also going offline, so with the audio.
Dheeraj, can I remove you from the stream too? Is that okay? Dheeraj?
Okay, let's start. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Physically, we are connected here on CPPCon, the biggest event in the world in terms of C++. Today, I will talk to you about the physical units library that we are working on for several years. I provided already a few talks about it, but this talk will be more scoped on my library rather than about the challenges, about things to do, and so on. So we'll skip some parts of it. We'll not talk about motivation today. We'll not talk too much about existing practice and challenges, because I covered this already on the talk a year ago. So you can find all the details there. And today we'll speak more about what are the results of our work and how the library stands comparing to competition. So here's the agenda for today. We'll have a short introduction to the subject of physical units. We'll talk about strong interfaces, how they help in making the library better, how they improve the user experience. We'll talk about the performance, runtime performance here. We'll talk about user experience in general. And then I will provide some introduction to the framework. It's not the whole framework introduction. We don't cover all of the details here. All of the details can be found in our documentation that I will provide you in a few minutes. And at the end, I will talk a bit about environment, compatibility, and next steps. I will try to address the Q&A backlog between those chapters. So please provide questions. While you provide questions regarding some specific slide number, please provide a slide number so I can easily come back to the specific slide and provide some answers. So without the further ado, let's start. What the physical unit is about. With physical units, we want to be able to provide different operations on physical units. In some terms, it's similar to what we have already in Chrono, especially Chrono duration class. So you can, for example, divide some quantity of specific dimension and with some unit, by a value, by a scalar, by some not a quantity. In such a case, you will just divide the value of the quantity, right? You can also convert between different units of the same dimension. When working with time, we can convert hours to seconds and compare them easily. Or we can add kilometers and meters and get result in meters. So again, it's similar to what we have already in chrono duration. However, this is new. We can provide different operations on different quantities over different dimensions. Those operations are multiplication and division, and they are used to change or provide a different quantity type as the result of the operation. So, for example, if we divide the length by time, we'll end up with the velocity here, with speed, in meters per second. We can compare the speed obtained here in kilometers per second with meters per second. All the conversions work as in the previous case. We can multiply the speed by time and get length. We can divide length by speed and get time. And of course, we can also multiply the same dimension, like length by length, and get an area, squared meters. And the next one is dividing length by length. So we can also divide the same dimension and get a dimensionless quantity with value 2 in this case. At last, we can divide the value by a quantity and get an inverse quantity of this type. So when we divide time, when we divide by time, we get frequency, right? So this is something different, something that was not in chrono duration. Chrono duration was allowed us to divide the quantity by a value, but not value by a quantity. So this is also something new here. Just to answer the possible question from the previous slides, we are using this prefix for the user-defined literals _q. And basically, we plan to replace it with q underscore when we move to the if we will be merged with standard library, because it's not for sure. We'll try to do it, but it depends from the interest. It depends from the amount of work needed to do it. We'll find out if it will happen or not. But we are trying to be prepared for it, and that's why I provided this q underscore prefix, because this prefix is a workaround to basically not collide with built-in literals. For example, if you would like just to type something like 2f or 2j or 2w, all of them are already taken by the built-in literals for some floating point numbers and others. And with this, we'll have a big problem for some units to express their units in literals. That's why we decided to go with q underscore and then unit, like you've seen on the previous slide. Also, we have some literals like S, H, or M, right, in chronoliterals already, and you don't want to collide with them too. We are also working on alternative way to create quantities, not only with UDLs, but you can read more details about it on the issue 48 on our GitHub, but it is too early to talk about it right now. Talking about documentation. We added a new documentation in last month. It's based on Sphinx. It's challenging, actually, to provide a documentation for a project written in C++20. There is a tool chain of tools we have to use. We are using Doxygen, we are using Sphinx, we are using Brief to generate those, and each of them has some problems with some specific C++20 syntax. So it was challenging, but I think the documentation is really nice, and I really recommend you to go to it and read if you are interested in the subject. And actually, you can find all of the details there. We'll not cover everything today. You can also test the library right away on the Compiler Explorer. To do this, you need to provide C++20 as the parameter for the compiler. You use some recent GCC and switch on the MP units library I released 0.60 version a few days ago, so it's CPPCon 2020 release, and all of the examples here will work with this release, even if you move further and break something, break interfaces in the future. So you can always refer to this tag 0.60 in order to be able to replay the code samples that we provided during this talk. NP-Units is also available in Conan. You can find it in Conan Center. I would like to thank you, my friends from Conan, that provided this Conan Center support yesterday in a few hours. Thank you very much, guys. So you can get it from Conan Center. You can just type np-unit 0.60 and you get the latest release. It's a header-only library, so it's really easy to use. Remember to use in Conan the compiler cpp std flag equals 20. Otherwise, the library will not compile. You have to specify that you are compiling with C++20 enabled. If you don't want to live with the latest release and wait for the next release for a longer time, and you would like to live ahead, you are welcome to use Bintray when we are hosting the latest versions of the stable packages that are created with every CI build that's successful. For this, you will have to provide a bit different ID in Conan and add the remote of our Bintray to your Conan configuration. Also, if you'd like to stay ahead, it's good to use -b outdated and -u to update recipes every time they are updated by us in the Bintray. Requirements for the physical units library that we provided, that we stated for ourselves, are as follows. First of all, and the most important part is to provide compile time safety, right? The library should not compile if there is something wrong with our calculations. Second of all, we should provide the best user experience. So if something doesn't compile because we provided some bad calculations, the compiler errors should be easy to understand for everyone, because the whole purpose of existing of this library is to generate errors every day for you, to find problems in your code. And it also should be easy to debug this code, right? It should be fast. Those abstractions should not introduce any runtime overhead. It should be as fast as Double, or maybe faster. It should be easy to extend, because we'll not provide all of the units, all of the systems that you probably need, so you can easily extend everything. You can add units, you can add dimensions, you can add all systems if you like. There should be no macros in the user interface, right? Because this is not a modern C++. We are not allowed to push macros as the user interface in the C++ standard library. So if you plan to standardize it as a freestanding part of the standard library, it cannot have macros, and it shouldn't have any external dependencies. Right now, it has a few, because there is no FMT in any compiler from C++20. Also, we are using MSGSL for expects, but actually it's not that important, and this dependency can be easily dropped. I hope that contracts will be in C++23, so we'll replace it with contracts in C++23. And that's all about the introduction. I see a question. So SI is a particular choice of base units for mass, length, time, temperature, etc. How to choose other non-SI base units? It's actually really simple to use it with different systems. We actually provide already in our repositories units from the international system, from US customary system. We have all system for foot pound second, and the whole system for CGS, so centimeter, gram, and second. We also started to work and provide the support for natural units. It's really easy to extend it. There is a dedicated chapter in our documentation about how to create custom systems. So I really encourage you to go there and read it. I can provide some insights during the talk, and if you have time at the end, I may provide also some additional details about it if there will be more interest about how to extend the library. But SI is the base, and probably SI will be the first one that will be standardized, if it will be standardized at all. So we are moving to strong interfaces. For our discussion on strong interfaces, I would like us to work on such a simple toy example. We will have a simple average speed function that takes length, that takes time, and returns us the average speed, right? So distance by the duration. I would like to provide the speed both in kilometers and time in hours, but also in miles, international miles and hours. And in both cases, if I provide kilometers and hours, I would like to have a result in kilometers per hour. And in other case, miles per hour, right? It should be compile time safe. So all of the problems should be provided during compile time. There should be support for multiple units and unit prefixes. So you can see right now that it's supporting already in international units. And there should be no runtime overhead. It should be as fast as implemented with double. And there should be no intermediate conversions being done to base units and back, for example. So this is how you can implement this with plain double, right? This is what I've seen too many times in production, working as a consultant in different companies. And it's also really common in open source to see things like this: macros, hours to seconds, kilometers to meters, and so on. And then you just have a function that takes double and another double and returns double. And there's a documentation saying the distance should be provided in meters, time should be in seconds, speed should be in meters per second. And this is only documentation, right? And it has to be, basically, it's a contract, and everyone has to obey it according to this contract. So if you want to implement this toy example 1, when we want to provide kilometers and hours, we take some two double values, convert them from kilometers to meters, from hours to seconds, do average speed, and return this one. Because we have to convert back from meters per second to kilometers per hour. And we do something similar to miles per hour, right? Then if you want to print it, of course, it will print a double value, so it will just print 110 and 70. And this is a correct result, right? But it's really easy to make errors here. So we want to make it better. Let's see how Boost Units does it. For all of the examples, you can find the Godbolt links here. You can provide them, you can type them and see how they actually perform in Godbolt, and see by yourself how it works. So in order to provide this simple example in Boost Units, you have to include a bunch of headers. There are not many aggregated headers that will allow you to basically include only one thing, and it will just include everything else. You have to remember about every single header to put here. It's really hard to provide all sets needed, and sometimes error messages are not that helpful to notice and to provide you information which header is missing. And then when we are implementing the average speed function, we provide here a helper for Boost Units, and we provide that it takes quantity of length and quantity of time and returns quantity of velocity, and does the calculation. Unfortunately, there is no support in Boost Units, even though it's really huge library, to non-coherent units. So if you want to work with something different than meter and second, you have to provide the support by yourself for many things. You have to create stuff for kilometer, for mile, for hour, for kilometers per hour, for miles per hour, provide your own dimensions and your own units for those, and constants of units for those. So it's not that easy to work with non-coherent units in Boost Units. So coming to our toy example with kilometers per hour, we get length in kilometer, time in hour. We call our average speed, but we have to explicitly convert every time to the destination. Destination was if you remember, length, time, and velocity. And actually under the hood means that these are SI base units, so meters, seconds, and meters per second. It is not stated here clearly, but it means that exactly. So if you want to convert this length in kilometers to length in meters, you have to do explicit conversion here, even though the conversion is really safe and it could be done implicitly, like it's being done by chrono duration. And the same goes for miles per hour. So there are no implicit conversions between quantities of the same dimension and comparable units. If you want to use those, Boost Unit uses this multiply syntax to create quantities. So you create 220 times kilo times meters and 2 times hours, and you get a result, and then do the same for miles. If you want to print it, it prints quite a correct text for miles per hour, but for kilometers per hour, I would say it's not the best output, but still valid. Another library that I would be referring here is a library named Units, implemented by Nick Holthaus. In this library, actually it's a header-only library with one single header that is really easy to include everything. And then you provide average speed of meter, second, and return velocity in meters per second. And if you want to call it, you provide kilometer, hour as an argument, and then they are implicitly converted to proper types, and then you convert the result back to kilometers per hour. When you try to print it, even though it returns you kilometers per hour, it prints it in base units, meters per second. So it's not exactly what we would like to have here. I see there is a question. Is it possible to take a dimensioned value and ignore the dimension in a given calculation? Yes, it has interface similar to duration. You can always get count. And with count, you just get a value from the quantity. So you are losing all of this strong typing here. Just before you call count, always remember about doing a quantity cast or a duration cast in case of duration, because you want to make sure that the unit is exactly which you intended here. So do not make any assumptions. Library may store different units in the type. So make a quantity cast on the quantity, and then you do count and get the raw value and work with, for example, legacy interfaces. But be careful, this is losing all of the safety here. And finally, the MP units, the library that I implemented with contributors. We are including here the speed in SI and speed in international units systems. And we have the SI length in meters, SI time in seconds. So here we are stating explicitly that we are working with meters and seconds. And we are turning meter per second and just doing the calculation. Then our example with kilometers and hours just implicitly converts those here because it's safe to convert kilometer to hour. It's made kilometer to meter and hour to second. It may not be safe to do it in a different order, but in this case it's safe, so you can do this implicitly. The same rules as in case of chrono duration applies here. And then we are quantity casting this to kilometer per hour and returning a type and the value in kilometers per hour. And the same for miles per hour. When you want to run this function, you provide here, to example one with 220 quantity in kilometers, 2 quantities in quantity of hours, and you get the output printed properly, as one would expect. However, until now, we were always taking the length in kilometers and time in hours. Then we're converting this to the base units, so meters and seconds, and then converting and getting the results in meters per second, and then converting back to kilometers per hour. And this is not the best idea in terms of performance, right? Runtime performance. We would like to be able to do this in one step, if you provide kilometers and hours, and we are interested in the speed in kilometers per hours, there should be no intermediate conversions. We should just divide kilometers per hours and get the result immediately, right, with one division. So how to do it? With doubles, it is easy. They will take everything, right? You just specify here that this is a double in kilometers, time in hours, double in miles, and everything works. Simple, right? With boost units, it actually starts to be complicated. We have to introduce templates, and it's not that easy to specify those templates. We are saying that it's a quantity of a unit, of a length dimension, and some system, and some representation, and this is our distance, and you're doing the same for time, and this is our time. And to say we are returning speed, we actually have to create the speed in kilometers per, or the speed in the destination unit by ourselves, saying that we are taking unit of length provided here, of time provided here, and we are dividing those. So actually we are here manually re-implementing the logic of the library. In case of Nick Holthaus library, it's also not that easy to do. Actually, we cannot easily provide those specializations here, like in the previous case, but fortunately there are type traits provided that you can use to provide enable if and basically spine on specific types. Because if otherwise, this will take everything. Strings, vectors, whatever, right? It's just a type T. But with enable if, you can specify that the first one should be length, another one should be time, and it's not that easy to specify that should be a velocity returned back. So this is only static assert provided as an implementation detail here, rather than the information provided directly in the function interface. However, we got concepts in C++20. When we add one additional header to boost units, we can work with isQuantity of dimension type trait, and we can create quantity of concept, and then say that we have concept length, that is quantity of length, time quantity of time, velocity quantity of velocity. And with this, we can implement all of the function in this way, with C++20 syntax of generic functions, right? This is generic functions similar to what we know for generic lambdas. Every time you see an auto as a parameter of a function or a lambda, then you know it's a template parameter under the hood. The same can be done for Nick Holthaus units. You may say that length is length, time is time, velocity is velocity, and then you have exactly the same implementation of the function. So as you can see, it makes everything simpler, it makes everything generic, and it's really easy to maintain and understand. And that's why this is the default and recommended case to work in our library. All of those concepts are already provided for all of the physical systems. So if you want to say, this is a length of any systems, I don't care. This is a time of any system, I don't care. This is a speed of any system, I don't care. I just want to return correct values. And this is what the code will do. Okay, we have a new question. Sometimes non-coherent SI units are necessary to ensure appropriate numeric precision. Is direct support for non-coherent units expected to solve this? Are there gotchas in library functions? Non-coherent SI units are supported, and it's really easy to provide those. The only problem I'm aware of with working with non-coherent SI units, and if they are not units that are basically derived with SI prefixes, so multiplies of 10, is that basically the ratios start to get really, really big in some calculations. So for example, foot has some pretty complicated ratio already in relative to meter, but if you make then a squared foot or cubic foot, it starts to be messy already. And with some more operations or some more strange things like, I don't know, electron volt or maybe astronomic unit, you will find out that that ratio can go out of precision, even though it uses 64-bit integers under the hood. So this is the only gotcha I know here with working with non-coherent units. But as long as those are the non-coherent units with SA prefixes, so just an exponent of 10, you are free to use them easily. And there should be no problems. Okay, next chapter is about performance. I make this transparent because you already see this code. I don't want to spend time you reading this because we already analyzed this. For double, the operations for all of the conversions through the coherent units provide 3 multiplies, 2 divides, and a bunch of moves. So some copies are being done. Actually, I was surprised to see those copies in the assembly. For boost units, it's pretty similar. We save 1 divide, so already boost units is faster than pure doubles. For Nick Holthaus, we don't have any of those copies, but the same number of multiplies and divides. And with our library, we don't have copies again, and we have only 1 division, so it's faster than working on doubles. At least in this case, implemented on the previous slide. When working with generic code, so if you want to just divide the values, then of course there's only a division provided here, right? If you provide kilometers and hours and want kilometers per hour, you just divide those and don't provide any intermediate conversions, and this is fine. With boost, there's also only 1 division, but some additional copies being done. Nick Holthaus, only division. Our library, only division. So as you can see, you don't pay anything comparing to using raw fundamental types with those additional abstractions that making everything type safe. And actually, in some cases, those abstractions provide even better performance than the raw fundamental types used under the hood. So it is type safe and fast in runtime. User experience. So as I said, everything here is about generating errors, right, and verifying our calculations. If there is an error, it should be found during compile time, not runtime. So in case of doubles, if you provide multiply instead of division and you say, I want to have speed, it's wrong, but actually it will compile fine, right? So all sorts of bugs can be provided here. There are errors of time. There are errors at runtime, but during compile time, everything compiles fine. If it wouldn't compile, then we wouldn't care and we'll never write this library because it will be already solved, right? The problem is to actually solve this problem that working on fundamental types is unsafe. And in times where a car drives for us while we sleep or play on the computer, it gets even more important to make it type safe and maybe save lives. If you make the same error for boost units, this is what you get as an error. In function, and this is a function name, if you will be careful, you will find 3 dots at the end of this slide. It means that it's not the end of the function name, of the first line of the error log, because this is still the first line stating the function where the error happened. This is the rest of the function name. And there's an error, could not convert some operator star. And again, we are out of this slide screen, this slide here. And even more operator star. And at the end, from quantity 3 dots, 3 dots, 3 dots to quantity 3 dots, 3 dots, 3 dots. And I assume you know everything, right? What happened here, what is wrong, or not. This is not the best user experience. It didn't compile, right? It's good because it is safe to use. But then you spend hours finding out why your calculation doesn't compile. And this is not the best user experience for anyone. For Nick Holthaus units, there is a different approach. There is no overload resolution process failing here, but there is a static assert stating static assertion failed, units are not compatible. So the error is short. There is a nice error message at the end, but actually there's information that there's instantiation of a function required from, and please tell me what are the units here, looking at the error log. Which units are not compatible? What was expected? What was provided? a bunch of ratios, right? It's, again, really hard to understand what's going on here. With the library we implemented, you have the information that in function, SI speed is a return type of this function. SI length in meters is the first argument. SI time in seconds is the second argument. And we couldn't convert for this operator star from quantity of an unknown dimension, because this unknown dimension had dimension length in exponent 1 and dimension time in exponent 1, right? Because actually should have an error here. Sorry, there should be a star. It's a bug on the slide. Because we should divide it, and then it will be -1 here, and this -1 will be speed. But with multiply, that is not visible here, there should be a multiply under the dot, then you should see exactly this result. So length multiplied by time, so exponent 1, exponent 1. So library tells you explicitly that it's an unknown dimension, and it has unknown coherent unit for this unknown dimension, and it was trying to convert it to dimension speed in meters per second. I would argue this is much better user experience for those error logs than in other solutions on the market. That's what we scope for, that's what we try to optimize for. We are still trying to optimize for, we are considering maybe getting rid of this exponent part here, but it's not that easy. There are always some engineering trade-offs to be done here. So as you can see, the library preserves nicely named types by the user by not using aliases. All other cases had those issues because they are using template aliases everywhere. We are using strong types to define speed, second, length, meter, and so on. Not just template aliases, which vanish during the compilation process. Another case is when you would like to assign an incorrect dimension to another dimension. So for example, here we want to create a quantity of acceleration, A, and we are basically in boost units multiplying meters, creating 100 meters divided by seconds. It should be second squared, not second, so there is one multiplication missing here, and that's why it's incorrect calculation here, right? And this is an error log. Error conversion from quantity unit leaves 3 dots, 3 dots, 3 dots, 3 dots, 3 dots, to non-scalar types 3 dots, 3 dots, 3 dots, 3 dots, 3 dots requested. And again, you know what's wrong here, right? In neat-Holocaust library, we provide the same. If you want to have acceleration in meters per second squared, and we again forgot to make squared seconds here. And you get an error that in instantiation of function convert with units ratio required from some type trait or type, ratio, static assertion failed units are not compatible. But again, it's really hard to find out what are the units here, what was provided, what was expected. With the library we implemented, we provided this acceleration expected in meter per second squared. We provide the same wrong calculation here. And there is information that error conversion from quantity of units physical SI dimension speed to in SI meter per second to non-scalar type acceleration in meter per second square. So as you can see, the library took this length in meters, this time in seconds, and after the operation division on those, it determined that it's a dimension speed provided by the user as a strong type. And the unit that's a result of this division is meter per second. And it basically reconstructed the strong types provided by the user. We call it the downcasting facility. I was speaking about this on the previous talk on CPPCon. So if you're interested in this, either see the talk or go to our documentation. But with this, the error log looks really nice, right? Because we know this is acceleration, we know this is speed. Library knows this is speed. Not an unknown dimension, right? Unknown dimension was in previous case because it was something strange. When something is correct, then we have a correct unit here and correct dimension. User experience is not only about error logs, it's also about debugging. So let's put a breakpoint in our correct division operation here for boost units. We get information that this is the generic function, right? This function that works with any dimension and of length, any dimension of time, and any units of those, and returns as velocity based on the input dimensions, right? So it just divides stuff. Kilometers per hour makes us the final velocity, one division operation. So we don't know exactly what are the types here, and we would like the compiler to tell us. And this is what compiler tells us for boost units. Again, we don't know exactly what was provided. For Nick Holthaus, again, we get a bunch of ratios on the list. For our library, we have information that basically this is a breakpoint in the function average speed that takes the first argument of dimension length in kilometers and the second argument of dimension time in hours. And now we know what we're working with, right? So again, I argue this is a really good value added to this domain by this solution that we used. Okay, I don't see any questions from this chapter, so let's continue to framework basics. How do you feel about such an interface? You have function foo that takes void pointer of argument named t and returns a void pointer. This is something we are laughing at, right? This is something we know from C. This is something that we say we are better because we have strong ties in C++. Right? We don't do such stupid problems. We don't make problems with interfaces because with strong types, we are able to provide explicitly what we expect for this function to be provided and what it returns, right? So let's see what we do. We are writing lambdas like this. We are writing function templates like this. And actually with C++20 generic functions, we can type it this way. We are writing classes like this. How is it different in terms of the interface documentation, interface specification than this C case? Of course, from the runtime point of view, it's totally different, right? This one will fail at runtime, this one will fail at compile time if you provide something wrong. But you know already that this error during compile time will be really long and hard to analyze. And actually, if you see something like this on cppreference.com or Doxygen or whatever other documentation tool as an API reference, you will not know what is expected and what will be being returned from this function. That's why I claim that unconstrained template parameters are the void star of C++. And we should do better. And we can with C++20 concepts. So what are the basic concepts in the library? The most basic concept is a unit. Everything depends on a unit. It's a building block of the library. Every unit of specific dimension is a scaled unit of some reference unit. So for example, for SI system and systems implemented based on SI, like we have implementation of international system, FPS, CGS, and many others, they still are based on SI units, so they are convertible to SI units. They have the same reference unit. So all of them are provided as ratios, as some scaled units of meter. Also, as you can see, every dimension here takes the unit as a so-called coherent unit. Coherent unit is a unit of the dimension as specified without any prefixes. So in SI system, velocity is specified in meters per second because the meter is a unit of length and time is a unit of seconds, right? For FPS, CGS, and maybe other systems, those will be different. So this is system specific. What is the current unit of specific dimension? If you want to create a simple unit in our library, so for example, you want to extend the library with a simple unit, you may create a named unit called meter. We are using CRTP pattern here. So CRTP stands for Curiously Recurring Template Parameter Idiom. And then next one is the symbol of this named unit. And the prefix means that it's SI prefix allowed to work with this unit. So you can create kilometer from meter using SI prefix. And this is what we do here. We want to create kilometer. So we take prefix unit, we provide CRTP again parameter here, and then we say kilometer. Kilo is the prefix of this prefix family for SI. And then we provide the reference unit to be scaled, so meter. As you can see, we are creating strong types here as an inheritance rather than using template aliases. And that's why the types don't vanish during compilation process. If you want to create something similar for time, again, we create second. We say that's a named unit of symbol S with SI prefix. And then you can say that minute is the named scaled unit with the symbol min. There is no prefix. There are no kilominutes, right? Or centiminutes. So there's no prefix for minutes. It's ratio 60 of second. So our reference unit. Hour is again a named scaled unit of symbol H, no prefix, ratio 60 of minute. Notice that you can reference also other scaled units, not always the base reference unit directly. So you can say that hour is 60 minutes and a minute is 60 seconds, and that is fine if you want to specify this way. Of course, you can also say that hour is 3600 of seconds, and that's also fine. It's up to you to decide how you want to specify your units. For a unit of direct dimension, direct quantity, you specify meter per second. We just say it's a unit, meter per second. We don't say anything about its ratio. We don't say anything about its symbol, because this symbol is being derived from the base unit, right? It will just take this M and S and will print it based on the recipe provided by the dimension that says that basically velocity is length divided by speed. And then if you want to create kilometer per hour, you can say that's a deduced unit. Deduced because it takes dimension speed, that I will show you on the next slide how it's specified. And based on the recipe in dimension speed, it applies kilometer for length, hour for time, and deduces what's the final ratio for kilometer per hour. So you don't have to care about those ratios by yourself. They will be just divided, multiplied as needed, and as provided in dimension speed recipe to just get the final ratio of kilometer per hour to meter per second. So as I said, unit is a building block that is basically everything in the library depends on. Then we have dimensions. Dimension matches a dimension of either a base or direct quantity, right? We have a base dimension here or direct dimension. Base dimension is associated with a unique symbol identifier for this base dimension and a base unit. Direct dimension has a list of exponents that can be either exponents of the base units or other direct dimensions, and it also takes a unit, a coherent unit of direct dimension. So for example, you can specify that dimension length is a base dimension with symbol L. This is what ISO specifies for L. And the base unit of this length in SI system is meter. Dimension time with symbol T, and in SI it will be second. And then you can say that dimension speed is a direct dimension, again, CRTP parameter provided here, with a coherent unit meter per second, so the one provided on the previous slide. And then you have exponent of dimension length 1 and exponent of dimension time -1. So this is the recipe to create our speed. And this is how the kilometer per hour knew that it has to divide the units provided for those on the previous slide. Then we have quantities. Quantity is a concrete amount of a unit for a specified dimension with a specific representation. There are helpers provided like this, length, that basically says that is a quantity of dimension length. And you can just provide unit and the representation for it. By default, it's double. And you can say SI length, SI kilometer as a unit, and the representation type as an integer. Quantity point is an absolute quantity with respect to some origin. So it's similar to time point that we have in Chrono library. It is created from another quantity value. And concepts are really useful, and they are used everywhere in our library. We also have dimension-specific concepts like speed, saying that speed is quantity of dimension speed. And what we're actually trying to do here is calculate fine for speeding. We provide speed as an argument and the price as a return type. So what is speed? It's a quantity of dimension speed. What's quantity of? Quantity of is a quantity for t, dimension for d, and the dimension in t should be equivalent to d. Quantity, right now, is a specialization of quantity, but we are thinking about making this more generic. For example, to work with chrono duration too. Dimension is either base dimension or derived dimension, as you've seen previously. Derived dimension is derived from specialization of derived dimension base class. And base dimension is derived from specialization of base dimension. And with this, everything works fine. Everything is strongly typed. We know exactly what to provide to every thing in our framework and in user interface. Next point is to provide conversions between quantities. For this, we have quantity cast, so similar to duration cast in Chrono. And we provide the destination quantity for the cast. But what's different than Chrono, thanks to concepts, we can specify quantity cast for dimension only, for unit only, or for representation only, leaving all other parameters of the quantity intact. So you don't have to provide all of the quantity all of the time if you want to change one thing at a time. I just see a question that does the library support non-integral exponents for base units to make a direct unit? Yes, it does support it. So you can provide dimension, you can provide the length is 1 second, 2, for example, if you want to square root something. If you square root the dimension, then you get the non-integral exponents in the dimension. It is supported. I don't see the second question. Let's see. How are operations like square root or cube root handled in the exponents? Exactly the same question as I said. Those will be provided by non-integral exponent parameters. Do the integral representation require the template types? Is 5q kilometer a double? No, 5q kilometer is right now an integer 64t as it's compatible with tooth chrono duration. But yeah, we know that it might be a problem, and we are considering making it double always, or you just have to put 5.q kilometer to get a double in the representation. And as I said, we are still working on something that's an alternative way to create units and quantities, but it's too early to talk about it. The library appears to benefit from concepts using a different capitalization scheme than types. Yes, I've been in the room in LEWG when we discussed a standard case for concepts, and this was really, really bad for my library. We have a thread on the issues list in our GitHub repository on moving to standard case for concepts, but as it happens that it's not that easy, because in some cases we want to have the type and the concept named the same, like quantity and quantity, ratio and ratio. And what to do in such a case? We don't know yet. We cannot find a good name. If you have a good solution, good idea, please go to our issues list and help us renaming those to standard case. I know will be really interesting discussion in LEWG when we provide this paper about this. Our representation casts implicits. Representation casts implicit conversions for representations is being done in the same way as it being done in the chrono duration. So you can always convert from integral representation to the double one, but not from double to integral because it's truncating conversion. Okay, and let's move on because we are tight on time, and I don't want to go over time, but I'm afraid I will go a bit. So let's continue. Concepts are not just a syntactic sugar over enable if, or maybe some specializations of the type in function arguments. For example, with concepts you can easily constrain the function return type, which is not easy to do with any other solutions we have in the language. You can easily constrain the user variable on the stack without any additional features with the language. So you cannot do this otherwise easily. Also, you can constrain class template parameters easily without introducing additional parameters to the class template and having to provide partial specializations for some specific Spine solutions here. So this is way better than you working with Spine, or way better than working with, for example, specializations of the types in function arguments here. That's why we work with concepts, and actually concepts also are much faster in compile time than Spine. I measured, it's way faster. You can find my benchmark results on my talk during C++ on C. Benefits of using concepts. Clearly state the design intent in the interface. So if you see the documentation, you know exactly what the author of the interface was meant for this argument. They're embedded in template signature, so present in documentation, simplifying and extend Spine. So it's not only enable if, not only void t, but even in those cases, it's much simpler and faster. Greatly improve error messages, because all of the error messages happen on the point of usage of the function, not deeply nested in the implementation error of specific function implementation. Another thing to discuss here is what would happen if unit was a constant, because this was a common solution like 10-15 years ago for physical units libraries, and it's actually brought even in ISO C++ committee lately, that a unit should be a constant rather than a type. So let's say that meter is just 1 meter, kilo is 1,000, kilometer is 1,000 meters, right? Second is 1 second, hour is 3,600 seconds. Then you provide this to our average speed, and then you get the result. Basically, what it does, it works always on the coherent units of the system. So there are a lot of implicit conversions being done. There's lots of precision being done. There are some runtime performance that hits you, because you are basically doing all of those calculations and conversions at the runtime rather than remembering the time during compile time. So we want to define units as types. Before C++20, those definitions had to be done with macros. So, for example, this is an example of Nick Holthaus. This is the extension of this macro. There are more macros here, and each macro looks like this one, providing many different instances of functions, type traits, and many other stuff to the library. And they said in the requirements that you don't want to use macros, and actually it's possible thanks to class types as non-type parameters, which is a new feature of C++20. You can specify seconds, minutes here, and then provide the ratio. And it works just fine. We can provide all of the information needed for a unit in one definition in C++ without using any macros. When you implement this named unit, there is a basic symbol text, which is NTTP parameter. There's ratio 1 provided here implicitly. That's entity parameter. You store this entity parameter inside the class as a static value. When you do prefix to unit, then you can easily multiply those entity parameters rather than using stud ratio multiply. You can just multiply those because those are values, not types. And you can easily merge symbols of the text for prefix and the unit because those are, again, values, not types. It turns out that it's simplified a lot in our library. For example, when you wanted to create some base unit ratio for all of the exponents on the list, we had to do some traditional approach with those recursive template instantiations. It's not recursion, but basically you truncate the list, get one, and calculate. With using values, we are able to just use fold expressions here, which is much faster to compile, much easier to maintain, much easier to write. I would argue that class types as non-type parameters is probably one of the most significant improvements in the template metaprogramming in the last decade. If something behaves like a value, it probably should be an NTTP. Please think about it in your code. To implement NTTP, I will not go into details here. You have to make members public because those have to be structural types, and structural types requirements require you to have public members, something similar to aggregates. For basic string, fixed string, it's the interface that is typical to the string. There are iterators, constructors, size, history, index operator, iterators, some operator plus, and operator equals, and starship operator, which is one more feature of C++20 that I really love, and it helps a lot in writing the library. It just makes a lot of code to disappear. Talking about C++20, we support text output. We can output by streams. As you've seen already, we can provide any quantity to stream, and it will print correctly a value and the unit. But we can also use FMT format. Right now, we are using Victor's library and waiting for the first implementation to come in the C++ compiler. So you can provide any format for the library. You can print only values or only units, or specify what's the separation between those, and have it printed. By default, we support Unicode, but with the A modifier here, you can specify that it should be ASCII-only output, and then you will get micro, U, second square, and an ASCII representation of it. We also cooperate with linear algebra guys that are providing P1385 paper, and is going probably to be standardized for C++23. So you can create linear algebra of quantities. I provide operations on those and get expected result. You can also create quantities of linear algebra, so revert the dependency. Now you're creating length of a vector. Vector is a representation type here. And again, doing the operations and output. This time, all of this is meter rather than, in previous case, meters everywhere in the vector or matrix. Last chapter, sorry for being a bit over time. We had many questions, and yeah, I will finish in 3 minutes. Environment compatibility next steps. Here is the list of features that we are currently using in the library. Concepts, class NTTPs, consistent and defaulted comparison, explicit of bool, down with type name, lambdas in inverted context, immediate functions actually we plan to use soon, and we are waiting for good modules implementations that we would work with, because it's really needed to provide SI implementation for all the system at once, for our case, with modules. From library, we are using concepts algorithms a lot, concepts library, of course, and FMT, which basically provides all of the formatting facility. Compiler support. We supported GCC 9.3 until 0.60. In 0.60 that was released 2 days ago, actually we had to drop it because of some problems with it, bugs, and the lack of features. So right now, the library is compatible with GCC 10+, and with the latest Visual Studio 16.7 with a few exceptions. The exceptions are that Visual Studio still does not support this nice terse constraint concept syntax. You have to type something like this, and then it works fine for Visual Studio. We are still waiting for Clang to catch up. As I said, there are plans for it to be standardized. If the committee will decide that it's no, then no. We'll not force everyone to standardize it. Then we'll just be the library on the GitHub. But anyway, I recommend you trying it and provide the feedback. We already dedicated a lot of hours in the committee about discussions. It seems that there is a lot of interest in the committee and in the industry to get it standardized. For now, the feedback is really positive, but actually we don't have it too much. We need more field experience and feedback from people. And getting to C++23 might be challenging because of it, because we lack feedback for now. Also, schedule is really tight. We already lost like at least 3 meetings, face-to-face meetings, and we don't know what is the future. And so the COVID doesn't help here too. And first of all, we want to ensure that the library is ready before we start the process of standardization. And to make sure about that it's ready, we really need feedback from you guys. If it's working for you or not, if there are any requirements not covered, or everything is fine. So please try and tell us about your experience and requirements. For companies, please provide your feedback from production or maybe proof of concept use and requirements you have for such a library. For authors of other libraries, implementation experience and production feedback. GitHub issues are not only to complain about something not working right? If you are happy with the library, please provide it too there. Say, we are using this in the production, it works really well for us, because this is a sign for us that this library is actually being used and it proves to be correct and fine for your use cases. It's really important for us to have such feedback. So please go to our issues list. You'll find a lot of discussions, next steps, feedback, and everything there. It's not just to raise problems. Last part, I would like to say thank you for everyone. It's not just me. This is a work of many people so far. I would like to say thank you to every author of every library in the internet, especially to Steven Watanabe and Christian Schabel for Boost Unit, for Nick Holthaus, that basically was an inspiration for this library to provide some interfaces. Martin Mene, Jan Sende for their libraries, which are really great, and other authors too. C++ Physical Units library is it's nothing new. We are working on this for many years. We know how to do it properly. We have working experience and production experience with it. We just want to standardize the best modern interface for it right now. I would like to thank you to my colleagues in the code, helping me with the documentation, writing first ISO papers about it, or just participating in the discussions and providing requirements. Contribution, as I said, is not only about developing code, it's also about providing feedback, sharing ideas, and so on. And special thanks to Walter Brown. Walter started to talk about standardizing physical units many years ago. Here is a paper from '98 from the conference when he's talking about SI library for unit-based computation. We may not agree with Walter on many or some cases, but the feedback from Walter is really appreciated, and I really value his feedback here and help. I would also say thank you to Howard Hinand for his chrono and date library. Those are awesome. I really learned a lot from them and took a lot of inspiration for this library. And last but not least, I would like to thank GCC developers that make basically GCC happen, that made Concepts TS as the only compiler supporting it in GCC 7, so 3 years ago. And we could start writing our implementation with GCC 7 and Concepts TS thanks to them. Thank you guys, you are doing a great job. Last, if you are interested about concepts, want to learn more from my experience, please join the concepts class on Monday. And that's all. Thank you guys. Sorry for being late, 8 minutes. I don't see much more questions here. I see Mark asking about what I want to say about the matrices and units in the library. We can basically talk about this in MAA discussions after the talk. We are already out of time. And with this, thank you very much, guys. There will be AMA session right away in this room, so we can discuss stuff after that. And thank you for being here. And stay safe. Okay, so we are right now in MAA session. I was asked to provide it also through StreamYard and with YouTube. So if you want to discuss something, if you want to raise the questions, you are welcome to put it in the Q&A. And we'll be discussing this over here. I can also just quit StreamYard and join you by the table. It's fine by me too. And there's a question from Mark about the hypothetical standards library attempt to integrate prefixes with C++20 chrono. I don't think it is possible to reuse stud ratio and prefixes provided in current C++. For example, these ratios provided there are not sufficient. If you will look there, you will find that there are 2 ratios missing on the up and the bottom of the list, because basically the ratio is too big to handle by int64t. This is why our ratio, the NTTP ratio that I shown you, has 3 arguments: numerator, denominator, and exponent, which allows us to handle really big ratios. And not be constrained by what stud ratio provides. So we would like to reuse stuff that are there, but it will not always be possible. What feature would I most want to see in C++23? That's a good question. Actually, there are 2 of them. One of them is the universal template parameter kind. We have a paper on this one already in the pipeline. This is about introducing something that's a template, but you don't know what are the parameters there. You know that there are 3 kinds of template parameters. There is a type kind, there is non-type kind, and template kind, right? So you can provide types, non-types, and templates to templates. But if you want to say that something is a class template, but I don't know what is there, for example, or I have specializations that will, in one case, will have NTTP there, another case will have type, and they'll have a template there, there's no possibility to create one primary template for this because it will not match the list. And basically, I would love to see the feature of universal template parameter kind to simplify the interfaces also of this library. So we can make type traits like a specialization of a generic type trait, because right now it's not generic and it shouldn't be standardized. I know there's a paper about it, but it shouldn't be standardized as long as this feature is not there in the language, because it will not work, for example, for stud ratio. It will not work for stud array, because those use NTTPs. And only this universal template parameter kind will allow us to create a type trait called is specialization of for such types. Second feature that I would love to see, and I found it just recently, is to provide context operator. Not only specifier, as we have right now in the language, but operator. Something like we have for no except, for example. You know that we can write no except, right? It looks really, really messy, but actually there is no except specifier and no except operator that queries if something is no except. I would like to easily also verify if something is context. I may be able to do it with requires expressions. I have to check it. But I found already some cases when I would like to provide different implementation for the case if something is context friendly and if it's not. I think that we can make even better performance in the division and multiply operations for quantities if we know that. Because right now I cannot just say that please compiler multiply all of the ratios for me, because I have to know what's the presentation type. If the presentation type provided by the user doesn't have context operator multiply, I cannot easily multiply all of those ratios in compile time. I cannot force it. I have to depend on the compiler to do it, and sometimes compiler is too lazy and doesn't do it for me. And so I want to be able to branch during compile time on the result of expression, if this expression is context or not. But I think it may be possible to do it with requires expression, but I have to check. And of course, there are a lot of other features, maybe not that useful for our library, like pattern matching, like linear algebra that I mentioned here, and many other stuff that will be useful for everyone, but maybe not this specific library. And I lack contracts. I was really sad when they were merged out from C++20. Concepts without contracts is like not having half of the hand. Are there any more questions? Because I don't see anything in Q&A. I see there are a bunch of people by the tables, but while I'm still here with the video, I can answer those for everyone. Which tools do I use for code profiling in Windows? Actually, I don't do this too much. I'm working on Windows all the time, but I'm working on a Windows system for Linux. And then there is what I do. And if I want to profile, I still have my laptop to be dual boot, and I boot to Ubuntu, and then you use perf to have native Linux behavior there. I don't profile much in Windows, actually. But there are really nice profilers from Intel, VTune and similar. I used them many years ago. I didn't use them for quite a while, but they prove really, really nice. Even for Linux too. They tend to provide probably better answers, what's wrong, than perf. But I used to perf, and I'm just using it because it's simpler for me. What are the most interesting topics of discussions from SG14? Frankly speaking, SG14 right now mostly scopes on the linear algebra, and I'm not interested too much in this chapter as a specification, and I don't have time to invest into it. I provide the direct feedback about my requirements for the Unis library to the authors, so I don't contribute too much to the SG14 lately. So I don't know if there are any other interesting topics, but through some time there was only linear algebra on the table. I am sorry I missed the talk, but I will check the library. Please do. Please check the library. Please check documentation on the GitHub pages. You will find all of the information I provided today and more in documentation. I spent a lot of time trying to make this documentation generated for C++20. It still has a lot of issues and errors, but I think it's a really, really nice documentation. So I really encourage you to go there. In case you have any questions, please contact me or raise an issue in the issues list. I will try to help you. But what's the bottom line? I mean, should I be using it? Oh, it was lost. Yeah, please use it. If you can access GCC 10 or the latest Visual Studio, you can use it right now. So please try it. Please use it in proof of concept. And provide me the feedback, provide us the feedback if it works for you or not. It should work. I hope it works, but if it doesn't, please let us know so we can fix things before we start the standardization process. And So we want to know both if it doesn't work, but you also want to know when it works for you, because people don't tend to share positive feedback with us. We only are informed about issues in the library. So, and we don't really know how much this library is already being used in production. We have last 2 minutes. Last question. How did I change the background in my camera? I'm using OBS. I'm using OBS and a green screen, so I can put everything there behind me. But for this, I need to have a really good light in order to make it really good quality. And also, I use a mirrorless camera. Does it work with another compilers? No, sorry, GCC 10 or Visual Studio 16.7, I think, the latest one. Clang still is lacking a few really important features to make it work. I know that there are some activities and development being done on branches, but nothing on mainline yet. I hope that Clang will join the party soon. Does the library do things with logarithmic units like decibels? Not yet. There is an open issue how to support the logarithmic scale. If you have any ideas or some maybe experience with working with such solutions, please let us know. We are still looking for the best solution to work with logarithmic scale. Do you expect JIT to play a larger role in the future C++ standards? I hope so. Especially, I would love to see JIT being used for concepts during compile time, because right now concepts tends to be really, really slow. In the talk provided by Hanna Dusikova a year ago, it was a keynote on C++ now. Hanna stated clearly that C++ concepts are slower than Python in the execution time during compile time. If it could be JITed and then run as an executable, the concepts will be really, really fast. But right now they tend to be slow. They are faster than class template instantiations and template metaprogramming, but still they are much slower than the runtime. Does the physical unit provide constants? Yes, it does. You can find all of this in the documentation. And with this, we are out of time. Sorry, guys. We have to stop. You will find me in the room, in the hallways for the next week and until the end of the week. And also, if you're interested in concepts and my experience from in C++20 with concepts, please join the class on Monday about concepts. I'm providing 2-day class on Monday and Tuesday. See you there or on the hallway or on the next CPCon conference, hopefully face-to-face. Thank you very much.